In this video, we will be looking at integration by substitution. So it's basically if you integrate the function of f of g of x and you have the derivative of g of x, and then you integrate in terms of x. So it looks very confusing if you just look at it at a glance, but we're going to do it chunk by chunk. So basically, this is the opposite of the chain rule. So we'll be looking at just a reminder of what we do in the chain rule. So let's look at this question as an example. If you were to differentiate, you will recall that from what we've done earlier on. You're going to just say 3, and then you're going to keep your bracket the same. So that's going to be 3x squared plus 2x. And then it's going to be squared, remember, because it becomes minus 1 of your exponent because you took it to the front. And then after we've done that, we integrate what's inside our, differentiate what's inside our brackets. So that's going to be all of that times with, and I'm just going to write it underneath because I'm running out of space, 6x plus 2. So if we look at that, it's basically two parts. It's this part where we differentiate what's inside of our bracket, and where we differentiate in terms of my exponent, really. And that's what the integration looks like. So if we integrate now, and we have to rewrite this in terms of an integral, can you see, then we will have this whole part of the 3x squared, 2x all squared, times with 6x plus 2 dx. So to make it easier for us, we're basically going to say this whole part that I have here, I call u, and this part here is u prime, right? So the derivative of u. So what this looks like now is we're going to have the integral of u du dx, right? Because we still need to remind ourselves, ultimately what we're doing is we're integrating in terms of x, and so we need to make sure we include that. So let's look at an example. Okay, if you were given this problem to integrate, then what you have to do is you have to find where your u is and where the du is. So if you look at this problem, you can see you essentially have something there to the power 4. So you're going to put that equal to u. So you're going to say u is equal to 3x squared plus 5x. And then what you have over here is your derivative. So what you're going to do now is you're going to go to this function that you've just called u, and then you're going to say, well, I will have to derive this function u in terms of x. So then I write it as du dx. And what this is 6x plus 5. So you will see that this is now my blue part here. So let's take what we have now and put it back into our original integral. So we have the integral of u to the power 4 du dx dx, because we still had that original dx from there. So if you look at that, so that just means we now have the integral of u to the power 4 du. So let's integrate that. That gives us u to the power 5, a fifth of that, plus c. So now all I need to do is I need to go back to what I called u, and I say, okay, so from this I know I'm going to have a fifth of my u all of this to the power 5 plus c. So by using this, you can see that this is a real quick way of getting your answer to something that initially might have looked very complicated. Let's do this one as another example. So what I would like you to do, if you feel like you're getting on top of what we're doing, maybe pause it right now and complete it yourself and then come back and check. So the first task is identifying the u, and I can see that this here is going to be my u. So I want you to realize that it's not the time to get bogged down about whether it's under a root or not. You need to find where is your u and where is your du, right? So my u is x squared plus 3x. So if I differentiate this function in terms of x, so du dx, I get 2x, plus, whoops, sorry, I took it as a plus instead of a minus. So I will just go back and erase that. So then you will see I've got minus 3x minus 3. So I'm going to rewrite my integral as the cubic root of u du. So we're not very comfortable with working with cubic roots, so we can rewrite that as the integral of u a third du. So if we integrate that, we get 1. So it's going to be plus 1, remember? So that's going to give you 4 over 3, and your fraction is going to be 3 over 4 plus c, and we're going to remember what we called u is x squared minus 3x. So we're going to substitute that, x squared minus 3x all to the power 4/3 plus c. Here we have another integral, and I want you to do the same thing again. Pause the video, try and do it yourself, and then come back and check to see what I have done. Okay, so I am going to start explaining what we need to do. So we have to identify my u. So as you can see, that what we have here and here are related. Can you see that? That the blue part is the derivative of the block that's just in red. So what we're going to do is we're going to start by writing down what our u is. So my u is going to be x squared plus x. Then I'm going to differentiate u in terms of x. So that's going to give me 2x plus 1. So I'm going to rewrite it in terms of my original integral. So I'm going to have du e to the u. So that just looks a little bit clumsy, right? So I'm going to rewrite that as the integral of e to the u du. So I know the integral of e to the u is just, the derivative is just of e to the u is just eu plus my constant, and I'm going to recall that I have u of x squared plus x plus my constant. If we consider this problem, when we just look at it initially, it might not look or feel like we can really use the u. But you need to remember that we have a rule for our integration where we have the integral of a constant times a function. We can write as the constant multiplied with the integral of the function. And this is going to come in really handy for us, because let's find what u will be. Right, so my u will be 5x plus 2. And if we differentiate with respect to u, if we integrate u with respect to x, we get 5x. So if we 5. If we look at this original problem, it tells us somewhere we're missing a 5. But we can multiply my whole integral by 1 and I don't change anything. So if I rewrite it and saying, well, but that's exactly the same as a fifth times 5 of my problem that I had originally, then this sorts out the problem that I have with my 5, because then I can take out my fifth and I have the integral of 5 and the cubic root of 5x plus 2. This makes it quite handy for what I need to do now. So I have 5 and the integral of the cubic root of u du. So this I can rewrite as a fifth integrand u to the power a third. If I integrate that with respect to u, I have a fifth multiplied with u to the power 4 over 3 times 3/4 plus c. So I'm going to have 3/20 of u to the power 4/3 plus a fifth times c. But my constant is a constant, so I can just keep on writing it as c. And then I'm just running out of space here. What you will have to do is you'll have to go and put your u back in like we have done with all the other problems. I would like you to try this problem for yourself before you look at what I'm doing. So again, pause the video and then come back and check to see that you can do it. So if we're going to find my u, we're going to start with saying, okay, I know my u is going to be 7x plus 2, and the derivative of u with respect to x is going to give me 7. So I'm going to have the same type of problem that I had initially, where I'll have to multiply it all by 1. So I'm going to have a 7th of the integral of 7 e to the 7x plus 2 dx, and that's the same as saying a 7th, and all I'm going to do is I'm going to rewrite that so that I have my e first, e to the u 7x. Remember from this, that's the same as saying my du is 7 dx. Go back to the previous video if you previous slides if you forgot how to do it. So I have d e to the u du. So what do I know about the integral of e to the u? That's just e to the u. So I'm going to have e to the u plus c, and so I'm going to have a 7th e to the 7x plus 2 all added with c.